Alright guys, our next unit here is right triangles in trigonometry. So we're going to be looking a lot at right triangles. Our first mastery learning objective says, I can write the ratio for sine, cosine, and tangent by identifying the opposite leg, adjacent leg, and hypotenuse of a right triangle. So we're going to have a lot of vocab to start. A right triangle, we should know what a right triangle is. It's a triangle. A triangle. Why is this? I don't know why it's not writing. Hold on. You know, the scribbles on the side. It was me trying to get the board to work. Right triangle. A triangle. With one right angle. Then the other two angles are acute. Okay, so that means right angle is equal to 90 degrees, acute is less than 90 degrees. Okay? So that's what a right triangle is, and then we have the sides of a right triangle. The first side that we have is the hypotenuse. The hypotenuse is the side across from the right angle. So if I have, like, here's my right angle, I go straight across the triangle, that's my hypotenuse, and it's labeled there, but I'll usually just label it H. Then we have what we call our opposite leg. Our opposite leg is the side across from the given angle. And the given angle will either be named by the letter, or it'll be shaded, or I'll have a little symbol. So for example, I don't know why I got cut off, that's Q. It also has this little mark. It also has this symbol, which is pronounced theta. Theta is just a variable. It's a variable that usually represents an angle. Okay? So if I go here and I go across my triangle, there is my opposite side. And then we have our adjacent leg. Our adjacent leg is the side next to the given angle. That's not the hypotenuse, pretty much. The hypotenuse is also next to the given angle, but that's not a leg. The leg is not the hypotenuse. So the side next to the given angle. The easiest way is kind of look where the given angle is, look where the right angle is, and between those two, that's your adjacent side. Okay. All right, so the first thing we're going to do is just identify the opposite, adjacent, and hypotenuse for the marked angle. So starting with the hypotenuse. Well, here's my right angle, hypotenuse. Easy. Opposite, right? Here's my marked angle, right? It's shaded. Across from that is the opposite. And then adjacent. Here's my angle. Here's my right angle. Between the two is my adjacent side. Easy peasy. Same thing for our next triangle. Start with the hypotenuse. Here's my right angle. Across from it is my hypotenuse. Then look at where your given angle is. Across from that is your opposite side. And then between the two angles is your adjacent side. So I think remember, one of the biggest things students seem to get confused on is what is a side. So just kind of like we look at the triangles, right? It has a start and a stop. So I'm calling this the hypotenuse. It starts here, stops here. It's that distance from that one point to the other point. Okay. Same thing with our opposite side. We call it here. It starts here, ends here. It's this side length. Same thing for our adjacent side, right between these. That one's the easiest to draw it already. Start and stop, it's our adjacent side. Okay. So it's very important to know our opposite, adjacent, hypotenuse side. We'll be using that terminology in all of our problems for the rest of this unit. Okay. All right. So then we are actually looking at what our trigonometric ratios are. And trigonometric ratios are simply the ratios and ratios are just writing two numbers as fractions. The fraction of two sides of a triangle. The ratios of two sides of a triangle. So if you look at our first one, right, these are just definitions now. We have three trig ratios. The first one is pronounced sine. It's abbreviated as SIN, so sine of theta. That's how this is pronounced. Sine of theta. And sine of theta is the ratio of the opposite side over the hypotenuse. Also abbreviated O over H. Change colors. That's taking too long. Okay. So that's just what the definition of sine is. Sine equals opposite over hypotenuse. Cosine, right, again, cosine of theta. That doesn't say cos theta. This isn't sin theta. It's sine of theta. Cosine of theta. And cosine of theta equals your adjacent side over your hypotenuse, or A over H. And finally we have tangent. Again, this is pronounced tangent of theta, not tan theta. Not going tanning. And it is your opposite over your adjacent side, or O over A. Okay? So those are the three definitions. These are our three main trig ratios. There's three inverse trig ratios, but we're not going to get, or reciprocal trig ratios, but you will not learn about those until pre-calc. So these are our three main trig ratios. And you will have to memorize these. These are not given to you on the test. The easiest way to remember them is I write it out like this. Start writing this on the top of every paper for a while and you'll start remembering it. So it's pronounced so-ka-toa. It's a nice, easy mnemonic to memorize those. Okay? But again, you will have to have those memorized for quizzes and for tests. All right, so let's look at an example. We're finding the sine, cosine, and tangent of angle D. The first thing we want to do anytime we're finding sine, cosine, and tangent is mark or label our sides. So we have the hypotenuse. We have our angle, opposite, right? It's the given angle. It gives us the angle here. So angle D is our given angle. So our opposite side. And then finally our adjacent side is the last one, right, between these two. So we have to label all of those. Sorry, I want to plug it in. So the first thing we are doing is finding the sine of angle D, right? So that's a sine of D. And that, again, the definition of sine is opposite over hypotenuse. And my opposite side is 14. And and my hypotenuse is 50. Okay. Then I simply have to reduce my fraction. In my mind, I see both of these can be divided by 2, so you get 14 out of 50. You can also type it in your calculator to help you out. But the calculator is in class. Do it automatically. If you're using your own little one, you have to divide it and then switch it to a fraction. Okay? But 14 out of 50 is the same as 7 out of 25 because both of those divide by 2. Okay. So that's for sine. So now we're just doing the same thing with cosine. Again, the definition of cosine is adjacent over hypotenuse. My adjacent side is 48. My hypotenuse is 50. We have to reduce both of those. They can both be reduced by 2. And we get 24 out of 25. And then finally, we are finding the tangent of D, which is, right, the definition of tangent is opposite over adjacent. The opposite side is 14. The adjacent side is 48. So when I reduce those, 14 out of 48 reduces to 7 out of 24. So those are my 3 answers. 7 out of 25, 24 out of 25, and 7 out of 24. Okay. All right, we're going to do the same thing with example 2. Again, start by labeling. So my hypotenuse is 30. My opposite side, well, I'm now looking at angle E. That's up here. So my opposite side is here. Okay, so again, this is in a different place than our last triangle because we're given an angle in a different place. And then my adjacent side has to be this one. Okay. So, we're finding the sine, cosine, and tangent of angle E. Sine of E. Again, the definition of sine is opposite over hypotenuse. My opposite side here is 24. My hypotenuse is 30. Then I'm reducing my fraction using a calculator, or I see that 6 can go into both of these. I get 4 out of 5. Okay. Then cosine of E. The definition of cosine is adjacent over hypotenuse. My adjacent side is 18. My hypotenuse again is 30. 6 goes into both of these again. So 18 over 30 gives me 3 over 5. And finally, the tangent of E. The definition is O over A. My opposite side, again, is 24. My adjacent side is 18. When I reduce that, again, 6 goes into both of them. I get 4 over 3. So those are my 3 answers for the sine, the cosine, and the tangent. All right, that is it for this video. No, number 3 is going to be an extra problem. Otherwise, go ahead and start watching that. Start watching that. Otherwise, I'll see you guys in class tomorrow.